So now we're going to take a look at the classification of matter. But once again, chemistry is the study of matter and the changes it undergoes. Matter, by definition, is anything that occupies space and has mass. So we might be able to touch it, we might be able to see it, but we also there can be invisible mass such as gases in the atmosphere. We can't see that or touch it, but it does occupy space and it does have mass. A substance is a form of matter that has definite composition and distinct properties. For example, gold, one of our elements, is an element. It exists as single atoms grouped together, whereas water and sugar, also substances, are considered to be compounds because their most basic units are composed of more than one atom or a group of atoms. Mixtures are combinations of two or more substances in which the substances retain their distinct identities. So what does that mean? That means, for example, if we dissolve some salt in water, we still have water molecules and we still have salt in a dissolved form. And mixtures can be separated by physical methods. So what I mean by that is, if we evaporated that water, our salt would be left behind. We can classify mixtures in one of two ways. An homogeneous mixture is a mixture in which it looks like only one thing. Sorry. By definition, on this slide, composition of the mixture is the same throughout. But again, using that salt dissolved in water example, before we dissolve that salt, so we have a pile of salt on the table and we have a glass of water, we put some of that salt in the water and it seems to disappear. However, it is still present. As I exemplified before, if we evaporated that water, we would leave the salt behind. So the homogeneous mixture looks like only one thing. And we could have more than salt in there. What if we dissolve sugar as well? It would still look like just one thing. Some examples given by your text: a soft drink, milk, and solder. Heterogeneous mixtures, on the other hand, do not look like just one thing, or the composition is not uniform throughout. Think about oil and water. When you mix those two liquids together, one floats upon the other, and that's due to differences in densities. So it looks like two different things. What if we pour some sand in a glass of water? Sand is not soluble in water. In other words, it doesn't dissolve. So we see the two separate forms, water and sand. Examples from your text: cement, and this is a picture of iron filings in sand, whereas you can see the iron, the black dots in there. So mixtures can be either homogeneous or heterogeneous. I mentioned a moment ago that mixtures can be separated by physical methods or means. And that is based on their different physical properties. Physical changes do not change the identity of a substance. Got to be clear on that, whereas chemical changes do. And here's a table that compares or describes different physical properties and techniques that can be used in a laboratory to separate components from one another in a mixture. We could use boiling points, and that's a process called distillation. So if one compound or substance has a low boiling point, the other one has high boiling point, we can separate those two by boiling. State of matter, solid, liquid, or gas. Let's go back to the example of sand and water. Sand, of course, is going to be a solid in water, and we can use filtration to separate that sand from the water. We can use a solid material in a process called chromatography. Volatility means or describes how easily something evaporates. We know alcohol to be volatile, and so we can easily separate that by evaporation. Densities, centrifugation and decanting, and solubility. So different substances have different solubilities in water, for example, and we can use a technique called fractional crystallization to separate components based on their solubility at different temperatures. So to define an element is a substance that cannot be separated into simpler substances by chemical means. Now that doesn't mean we can't break up the atom of an element, but that would require nuclear means. So we're just talking about chemical means here. I haven't changed this slide yet, but I did take a moment to take a look at how many elements there are present in the year 2020, which is where we are. There are now 118 identified elements. Let's see, what was it? Oganesson and 3 other elements were added to the periodic table in 2016. Oganesson is a radioactive substance classified as a nonmetal, and in fact has been added to the noble gas family. It was actually discovered in 2002 by Russian scientists. However, it has taken a number of other years in order for another scientific group to also create or synthesize this element. In order for an element to be accepted as a new element, there must be at least 2 labs to successfully generate or synthesize an element. 90 elements occur naturally on Earth, and of course that number 33 would be updated too, because those are the elements that have been synthesized by scientists. So another term, compound. It's a substance composed of atoms of 2 or more elements that are chemically united in fixed proportions. Okay? So compounds can only be separated into their pure components or their elements by chemical means. So in order, and examples of compounds given here, glucose, ammonia, and water. These elements are chemically bonded to one another to form this compound. So just to summarize the classifications of matter, there's this, you have this flow chart from your text. Matter being the large encompassing header here. So matter can take two forms, mixtures or pure substances. Mixtures can be separated by physical means into the pure substances. If we have a mixture, we can also classify that as either homogeneous or heterogeneous. Homogeneous mixtures look like one thing. Heterogeneous mixtures look like more than one thing. If we have a pure substance, it can be classified either as an element or a compound. Elements cannot be broken down chemically into smaller components, whereas compounds using chemical means can be separated into their individual component elements.